So now we are doing assignment 2, number 2, the stuff that we didn't do back when we did assignment 2 the first time. And these are some 4 problems that we're going to be looking at to see when the interval actually converges. So let's start with 1a. Of course, I mean 2a. So we have something here that is clearly going to be a series that is, potentially going to converge, right? Because this x, if this x was really small, right, we think it's going to converge, right? But if x is really big, I'm not so sure. So whenever we have exponential functions and I see stuff like this with another n, my go-to ratio test. Okay, so let's figure out the ratio. So that is a sub n plus 1 over a sub n. Okay, this is the n plus 1 term, this is the nth term, and we're going to look at the ratio and see, well, I wonder if this actually is going to converge. Well, it depends on x, right? It depends on x. So let's just have some fun times with algebra, because algebra is awesome. Every single time. I'll get it one day. Okay, so n plus 1 over n is 1, right? And this is just going to be, well, this is just going to be x, right? And this is just going to be 2. Oh, sweet. So we don't even need the limit anymore, right? Rho is going to equal just x over 2. And if we want this to be less than 1, what does that mean? That means the absolute value has to be less than 2, which means x has to be between -2 and 2. Of course, I need to put it in the right order, don't I? There we go. Okay, so we have -2 and 2. We want to move on to 2b, don't we? Of course we want to move on to 2b, but we can't because we have to test the endpoints. We're not done yet. So we have to then say, well, what happens when x equals -2? And what happens when x equals 2? And this actually works out pretty nicely because it becomes pretty clear. If you put -2 in here, what are you going to get? Well, you're going to get n times -2 to the n over 2 to the n. What's -2 to the n over 2 to the n? That's just -1 to the n. If you plug in 2, it's just n, right? And folks, it doesn't take us long to realize that neither one of these, right? Neither one of these is going to converge because neither one has any chance. It's got no chance because by the divergence test, it's actually not approaching 0, so both endpoints don't work, so therefore that is our interval of convergence. The radius, folks, would be 2, right? If you ever asked for the radius, it would be 2. More fun times. So, folks, we're going to see a pattern on these pretty soon about these endpoints, at least for these problems, but let's check this one out here. Right. Well, we have something to the n, we go to the root test, right? When you have something to the root test, that's your go-to. See if I can do this one correctly. Whoop. Yeah, that's correct. And the cool thing is the n and the 1n are just going to cancel each other out. And we don't even need the limit anymore, right? The limit is not even needed. This is just going to be x squared plus 1 over 3 with a nice little absolute value. And therefore we have x squared plus 1 is less than or equal to 3. And, oh, that means we have this. And, well, this is going to be a little funky, right? Oh, this doesn't work, right? I mean, this doesn't really work. This whole area doesn't work because x squared can't be negative. So we're going to do this. And then we're going to say this, right? Oh, but, oh, now we have a problem. When x squared is less than or equal to 2, now we have to go back. Why did I write 3? I have no idea. But now we're going to go back and recognize that we need to put it back in there, right? Because this part here is kind of irrelevant, right? This kind of here is irrelevant. We really don't need this. We just know that x squared is less than 2. But whenever we have the square root, when we're taking the square root, we have to think about when it's the positive or the negative root. So that's why that's our interval. And of course, now we have to test endpoints, right? So when we come in, we say, hey, what happens at, why am I doing 3? Jeez, come on. Right? So we have to test these two. And the cool thing is that no matter which one you test, right, plug in negative root 2, plug in 2. Well, they both get you the same place, right? Because whatever one happens, you both get to 2 here. So they're both going to turn into this. Well, what's 2 plus 1? 3 over 3. Oh, just 1 to the n. which last time I checked is just 1 plus 1 plus 1. I can't even write 1 plus 1 plus 1. But you get the picture, right? It's just like the one we did previously, right? It's just like the one we just did. 1 plus 1 plus 1 plus 1. The limit of this as it gets really large is not 0. It diverges when x equals both negative root 2 and positive root 2. So this is indeed our good interval. We don't have to worry about those endpoints. Wow, maybe none of these endpoints are going to work, right? Maybe just every single one of them. Maybe we have to work till future lessons before we have endpoints that actually are relevant, right? All right. Sorry, I forgot to hit pause. So you had to watch me. You have to endure me writing that out. Okay. Oh, this one looks fun. Got a 2n up there. Okay. Well, again, I'm going to the ratio test. It's my go-to whenever I have some exponential and some non-exponential. It's my go-to first step. Sometimes it doesn't work, but it's my go-to first step. All right, this one's not going to be quite as fun because you're going to have n plus 1 squared here in the denominator, and this is nice and clear. But here's where it gets a little bit tricky because we're going to have, let's see, we got 2n plus 1 plus 1. That's actually like x to the 2n plus 3, isn't it? Right? Yeah, I think it is. Oh, that's going to be a little funky, isn't it? Okay, so we're going to have x to the 2n plus 3 over x to the 2n plus 1. And then this can also be n squared over, and this is kind of, we know what's happening here, right? This is just going to be equal to 1, right? This right side is just going to equal to 1. So this is going to be what? Again, come on, Poprick. I know some of you caught me on that too. Oh well, I'll get it one day. Okay, so this turns into 1. This is just the absolute value of x squared. Oh wow. Well, absolute value of x squared is just x squared, right? And we want this to be less than 1. So therefore, we want x to be less than 1 and less than negative 1. And given the fact that the endpoints never work, we should just not waste our time, right? Wrong. We always have to test the endpoints. Okay. Well, we get, what, negative 1 to the 2n plus 1 all over n squared. And here we have, oh wow, just 1, right? 1 to the 2n plus 1 is just 1, so just 1 over the n squared. Oh, look at this. Look at this, folks. Look at this. 1 over n squared has a p that equals 2, which is greater than 1. So by the p-test, this converges. It's about time, right? And guess what, folks? This converges. That means this guy here, well, this guy has got some negative 1 going on over here, but so what, right? So what? This sign doesn't make a difference. This is actually negative 1, to be honest. But it's just negative 1, because no matter what n, that's always going to be a positive number. So it's just going to be negative 1 to the first. It's just like the negative version of this. It's also going to converge because this converges. That means this is going to converge absolutely. The signs don't even make a difference. The negative 1 doesn't really make a difference because it's just, this denominator is getting big so fast. So they both converge. Sweet. Oh, that's awesome. Look at that. Radius, if you were asked, what's the radius, folks? If you were asked, you weren't asked, but if they were asked, the radius is 1. The radius here was root 2, right? Here, if you were asked, the r was 2. You weren't asked, you will be, potentially, in the future, in a calculus class in the future. 2D. All right. This one looks fun. Factorials are fun. And again, I mean, I feel like a broken record. Watch this, folks. Ready? Look, I remembered. I know it's a first. But factorials, exponential functions together, ratio test, okay? It's like kind of your go-to for this kind of stuff because you want to kind of, the ratio is kind of telling you what's happening in the long run, right? You want to know what's happening in the long run. So the ratio test is something that's going to tell you what does this look like in the long run? Does this look like a geometric series in the long run? Okay, so a little bit of quick manipulation. We're going to get 2x. I mean, I'm going to write it out just because, I mean, I'm writing a solution guide, right? I mean, I could take a shortcut, but you don't really take shortcuts when you're writing a solution guide. So we'll write this out. And we're going to keep on going. N factorial fun means that this n factorial over n plus 1 factorial, I mean, I'm not going to go through that again, but that's just going to be, 1 over n plus 1. So the weird thing is that the last few problems, these have just become 1, but this time it's not, right? We're going to get this, 2x over n plus 1. And we want this to be less than or equal to 1, right? This is a bit of a head scratcher, right? Well, for what values of x is this actually going to get closer and going to be less than 1? Well, n's going to infinity. So 2x, what if I made x like 1,000,000? Well, infinity is bigger than 1,000,000. In fact, there isn't a value of x that I can put in. There's nothing I can do. I can't put in some number for x that's going to make this actually get closer and closer and closer to 0, because I mean, closer and closer, it's going to be greater than 1, because it's always going to be closer to 0. This denominator is going to get huge no matter what. No matter how big of an x I choose, it's not going to work. Uh-oh. What does that mean? Well, it's always going to be less than 1, isn't it? I mean, isn't this number always going to be huge? I mean, here I am thinking about, for what values could I put in here that's going to make this not work? And I got nothing. I think it's always going to be equal to 0, right? I mean, put in 1,000,000. It's going to equal to 0. And 0 is less than 1. So I'm kind of like, x is kind of all real numbers, right? All real numbers. Yeah, no matter what you put in there. Put in 11, it'll work. Put in 1,000,000, it'll work. It's always going to be less than 1. Sweet. Okay. Well, I guess we could write this differently, right? How could we write this? I mean, that works, right? Interval notation, what would we say? We'd say negative infinity to positive infinity, right? With, I guess that's the interval notation that we would use. But it's all the same thing. All real numbers. Sweet.